Welcome to Chapter E. So, this chapter is sort of an introduction for what's coming ahead. It's some stuff that you should understand and know before we get into the bulk of this semester. So, in this chapter, we're going to talk about measurements, types of measurements, units, how to calculate density, and a couple more things. So, let's go ahead and start. There's two types of measurements. We have qualitative and quantitative measurements. Qualitative measurements are observations. This is where we're looking at what color our substance is, what physical state it's in, is it a solid, liquid, or gas? Quantitative measurements or observations are something that includes a number and a unit. Also, we can look at counting values. So there are 3 people at a desk. That would be a quantitative observation. Or something is 35.5 meters long. That would also be a quantitative observation. So all of our measurements consist of 2 parts. We have the number and then the unit. We're going to talk about different units. We're going to use lots of them. We're going to convert between them, but we right now are just going to focus on that we have a number and a unit. Now the units that we're going to use, they do vary, but there is something called the standard units of measurements, or called the SI units. This is, they're different for what we're measuring. So for length, the SI unit is the meter. For mass, it's the kilogram. Time is seconds, and temperature is Kelvin. And then amount, which this will be super important as we progress through the semester, amount is what we call a mole. And we'll describe that in more detail as we go forward. And then we're not going to worry about the other 2. When we're making measurements, generally speaking, when it comes to anything in science, we do it in the metric system. So the metric system is based on a power of 10. This is something that you have to have memorized. So we need to understand what all the prefixes mean. So if we have a meter, let's say, then we can reference that meter to other prefixed units, like a centimeter. Centimeter is 100th of a meter. So there's 100 centimeters in 1 meter, and etc. And here's kind of, I like to look at it in these terms, not in terms of decimals. So here we go. Here's kind of what I call our base unit. And this could be a gram, it could be a liter. It doesn't really matter. We're just using the meter as a thing to reference. So 1 kilometer is 1,000 meters. So kilo means 1,000. A megameter, mega means 1,000,000. Deci is 10, centi is 100, and milli is 1,000. So those are the main ones that you need to understand. Okay, moving on to temperature. So temperature, there's 3 temperature scales we're going to use. We have Fahrenheit, Celsius, and Kelvin. We can convert between all 3 of them. Kelvin is what we call the absolute scale. Kelvin has what we call absolute 0. So 0 Kelvin is where life basically doesn't exist. So nothing can survive at absolute Kelvin, and that is sort of the purpose of that scale. Then, of course, you're familiar with Celsius and Fahrenheit. And in science, for the most part, Celsius is what we're going to use. So to convert between these, you're going to use these temperature conversions. So if we look at going between Kelvin and Celsius, we're going to use this equation right here. Kelvin is equal to degrees Celsius plus 273.15. So we can just convert using that equation. Go ahead and write that down. We can convert between Celsius and Kelvin. And then down here, we have the conversion between Fahrenheit and Celsius. So degrees Fahrenheit is equal to 1.8 degrees Celsius plus 32. So you're just going to plug one in for the other to solve for the other. And if you go back up here, Let's say that we have a body temperature of 37 degrees Celsius, and I want to know what that is in Kelvin. I'm just going to add the 273.15 to it. And then you can go from Kelvin to Celsius as well. Okay. When we talk about measurements, we also need to talk about something called precision and accuracy. They're two different things. Precision is simply how close you are to, or how close your measurements are to each other. It doesn't have anything to do with whether those measurements are accurate or not. It's just how close they are to each other. Accuracy, that is how close you are to the true value. So you can be accurate in your measurement, but you don't necessarily have to be precise, same as you can be precise but not accurate. Every measurement has some sort of uncertainty to it. And that uncertainty lies in what we call the estimated digit. And we're going to talk about that here in just a few minutes.